Good afternoon, everyone, and welcome to AABC's Tab Talk webinar series. I'm Colleen McCain, Marketing and Member Engagement Manager with AABC, and I'll be your moderator for today's webinar. Thanks to all our members and non-members across the community for participating today, and a special thanks to Belimo for supporting this webinar. I have a few housekeeping notes before we get started. If you have questions for our speakers, please use the Q&A button in your Zoom window, not the chat, and we will feed those questions to our speakers at the conclusion of the presentation. You can submit questions at any time, no need to wait until the end. If you have technical issues, please use the chat box to inform the panelists and we will assist you. And finally, concerning AIA learning units, if you are an AABC certified TBE or TBT, please allow 7 days for your CEUs to be uploaded automatically to your portal. Today's session topic is fire smoke damper testing and fire life safety system maintenance at your facility. Our experts joining us today are John Herboth from Northwest Engineering Services, Inc., Larry Felker from Belimo, and Troy Byers from Byers LLP. John Herboth is a senior commissioning project manager at Northwest Engineering Service, Inc., with 14 years of experience in building, commissioning, and healthcare facilities. He believes that sharing project successes, failures, and best practices are a professional duty. Larry Felker is a mechanical engineer and fire smoke product manager for Belimo Americas. He has specialized in actuators and dampers for 25 years and is co-author of Dampers and Airflow Control, ASHRAE Special Publications. He is a member of the Society of Fire Protection Engineers, National Fire Protection Association, International Code Council, and a life member of ASHRAE, where he serves on TC 5.6 control of fire and smoke. Troy Byers is a consulting engineer with over 25 years of experience in TAB and CX training, and serving aboard nuclear-powered submarines led to a passion for not only mechanical engineering, but also life safety systems. Now, without further ado, I'm going to hand it off to John to get us started. Take it away.
Thank you. Give me 1 second. Going to share my PowerPoint. There we go. How does that look?
Can't see it just yet. You got to steal the screen.
That says I'm stealing it. Give me a second. Oh, the wonders. Let's try it again. Oh, now.
Okay, there we go. If you want to advance to the next slide.
Will do. All right. Let's get started. This is an AIA continuing education presentation. We're not here to sell any products, and we're not here to sell our companies. We're here for teaching. So we'll continue on. Just briefly to go over what we're going to discuss today. You know, fire smoke dampers, you name it, any type of damper, and dedicated smoke control systems, non-dedicated systems. We're going to be covering these different components and systems, and at critical healthcare facilities like hospitals and connected buildings, this has been routinely enforced to get these tested on a 6-year cycle and 4-year cycles for non-hospitals. But enforcement has been changing, even though it's been in the code for a long time. So we're going to talk about code, and we're going to talk about enforcement. We're going to talk about how critical these components are and the different aspects of them, and then a few projects to go through it. The learning objectives here are to discuss changes in enforcement. We're also going to review some typical aspects of fire life safety maintenance agreements, and what the periodic inspections and maintenance aspects are, and what are missing. And then we're going to discuss why damper and fire alarm relay devices need to be regularly tested, and then identify some best practices, as well as ongoing maintenance testing, access, record documentation, all the fun stuff that TAB and commissioning professionals are pretty regularly familiar with. With that, Larry, would you like to join us? And we're going to get to your section.
Hello. You could move to the next slide.
Sure thing. Go ahead and share your video as well.
Doesn't seem to be showing. So I'll just continue on.
Looks good. I can see it.
Oh, there it goes. I can't see it on my screen. But just to distract you, I'm gonna put it off here. Periodic testing and repair of all life safety dampers is the building owner's responsibility. And fire department has not been enforcing the codes too well. They're overburdened. And this is not a UL issue. UL, once your damper is installed, it becomes responsibility of the building owner and any local code officials. That's clearly stated in both the IBC and IFC, the International Building Code and the International Fire Code. Now, those two codes refer to UL standards, the UL 555 family of standards for new construction, factory installation, what actuator can be used on what damper. But once the dampers leave the factory, except for the framing and following the directions that the damper manufacturer includes, the local authority having jurisdiction is in charge of the dampers.
Yeah, Larry, we run into that a lot where we've had people talk about you have to replace the whole assembly and to protect UL listing. So that is something common that we run into all the time. People want to point to it. And
Yes, I do too. NFPA 80 and NFPA 105, which are coming up. I want you to flip slides and we'll get those numbers up there. The codes refer to NFPA 80 and 105 and 92 for testing and for requirements. And those standards require repair of dampers. They do not require replacing. UL 555 is a factory standard. Once it's in the field, changes are going to be made. Like any appliance, you're going to repair parts. A damper is considered an appliance, just like a refrigerator. If you change the thermostat in it because it broke, you're not going to find that you have to get recertified.
yeah, that's right. And I think for the most part, you know, it's function over everything. You replace the thing and you need to make sure it functions correctly and fail safe.
Yes. So the two main codes refer to NFPA standards, 80 and 105. They aren't long. 80 is fire, 105 is smoke. The sections aren't long, but they clearly require testing and repair of a damper. You can replace it if it's not in good condition. Blade clash, you're never going to get the blade straightened out in the field. So in a case like that, you'd have to change the damper. It's rare. Next. So to rub it in, it's the owner's responsibility to take care of this and not the fire department or building officials. Next. Here are the periodic testing requirements. There are some exceptions, particularly in the smoke control, because you don't want to be closing a damper or opening a damper and causing any damage to ductwork. But Chapter 7 dampers, which are the containment dampers, and about 90% of those installed after commissioning, got to test them at the end of the first year, and then every 4 years, except hospitals every 6 years. I know that's sort of backwards, but hospitals are very good about taking care of things, and commercial buildings are not good about taking care of their dampers.
But that's primarily because we have, you know, enforcement there on a regular basis, right?
Yes. The Joint Commission inspects hospitals and makes sure that they're in good shape. The Chapter 9, the smoke control system dampers, if they're dedicated, they've got to be tested semi-annually, twice a year, at 6 months intervals. And if they're not dedicated, if they're part of the HVAC system, then they have to be tested annually. And there are a number of other systems that are included in the annual testing, particularly CO2 systems and waste dampers, elevator. Next. What I encourage is that all contractors quote testing on all of their bids. At the end of the first year, testing should be included in initial construction documents. The engineers don't put it in there. The sheet metal contractors should promote service contractors so that the periodic testing gets done. And the smoke control system does need a test and balance contractor. The dampers themselves in a few locations need a certified contractor, but anyone actually can do the testing in most cases. But oftentimes that means that the fox is guarding the chicken house. So you really want a contractor qualified that's in there. And then all the testing contractors, yeah, well, and then all the testing contractors should make sure that the facility knows they're supposed to do this. Very often they don't even know it, and then they get a surprise. And if you've got a chief who's been in the building for 10 years and has never mentioned it to the owner, and then suddenly he gets nailed, it makes him look bad. He should ask for it in his budget every year.
Yeah, we did have somebody ask, who's a qualified contractor? And I'll take this from the start. Depending on what jurisdiction you're in. I'm in Oregon. We do work in Washington. We do work in Idaho, Montana. But in Oregon, certain credentials you have to have, especially when it comes to smoke control systems. Whether that's a tab certification in NICET, and in Washington, Larry, me and you were talking about this previously. Now there's a very specific ISO standard that is currently only available through a sheet metal union. But we talked to the state fire marshal, and they're putting a pause on that till there's multiple routes for different parties. What have you experienced, Larry? Qualified contractor. I mean, our CX certifications, PEs, and tab certifications typically have been good enough for most areas that we do service in.
Yeah, I'm not really qualified to say who is qualified. I can tell when I'm talking with a contractor who knows what he's doing. But you want a qualified tab contractor.
Yeah, and I think
whatever the local rules are, I
Yeah.
would follow them.
I think the most important thing, and I'm sure Troy would agree too, is your main point of having that first year testing on the alternate bids is so important, so that it's not the maintenance team that also has to scramble to take care of it. It promotes definitely a team attitude to taking care of a capital or retrofit project and making sure that it captures that 1 year need for retesting. Especially on smoke control systems, where a lot of places don't have somebody that is capable of doing that. And so it's a great relationship to have with mechanical sheet metal contractors as a tab provider or a CX provider or a consultant provider for smoke control systems to make sure that you take care of that need that's going to come up in such a short amount of time during that warranty period.
Yeah, it can be an alternate in the bids. Low bid is going to tend to win most contracts, so it should be an alternate so that it doesn't price them out of the contract. But if all the contractors are quoting testing, they will start to get some.
Yeah.
And then, of course, as time goes on, when dampers are tested and anything fails, then they get to work for repairing them, rather than seeing dampers fastened open.
All right.
Next.
I'll let you continue.
Okay, so UL 555 and 555S are factory standards. They test the damper, cycle the actuator and damper. It's tested at elevated temperatures and its leakage. But once installed, it's your AHJ who is in charge of everything. And then, of course, any local standards or codes override the national. There's some cities who require once a year testing. But once in the field, UL doesn't regulate that. NFPA 80 and 105 are referenced by the codes and they take over once installed. And they say, repair the damper as soon as possible. And your actuators are your number one failure point. They're the most complicated part of it. Next. So Chapter 7 dampers are standalone dampers. The actuator and damper themselves are not connected to the firefighter's smoke control panel or to the fire alarm panel. The smoke detector is wired to the fire alarm panel. So on the left side, Chapter 7, the damper stands alone with the smoke detector. Chapter 9 dampers, which is smoke control, are going to be connected centrally, either to fire alarm or to the smoke control portion of it, a UUKL panel. And it's important to remember those distinctions because those determine your testing requirements also. With Chapter 7 every 4 years, Chapter 9 once or twice a year. And that is confused in engineers' specifications for the dampers, particularly for the switches. So Chapter 7 is compartmentation. They're containment dampers, and their purpose is to stop fire or smoke from jumping out of the compartment of origin into other areas of the building. Next. Chapter 9 are much more complicated. We're going to see them in all the applications that are listed there. There are about 10% of those installed, and their main purpose is either to pressurize a space so that smoke can't flow into it, or to exhaust smoke so that it leaves the building. Stairwells shown there on the right side are a very typical example in most buildings where we're going to keep the stairwell pressurized so that people can escape in a relatively smoke-free environment. Next. So there's Chapter 7 on the left. The controls are a smoke detector within 5 feet of the damper. And then you'll have a high temperature limit, typically 165 degree, 90% of the time. And then your actuator. And if you detect either smoke or you get an elevated temperature in the duct, the actuator power is cut, and it springs the damper closed. Chapter 9 are going to be a lot more complex in most cases. So right there is shown on the right side a reopenable damper. It can be overridden from the firefighter's smoke control panel. There's position indication required so that any of the incident commander during any event can see whether dampers are open and closed, and they can get messages from any firefighters on the floor whether they need to exhaust smoke or to pressurize the space. So they're a lot more complicated.
A lot more fun.
Next. Now, when you go to look at some of them, and this one's typical, you can't tell really whether that is a Chapter 9 or a Chapter 7 application. The red conduits give you a definite indication that it was installed by a fire alarm contractor, but we see a mistake up at the top. Oh, fire damper. Well, it's not a fire damper. It's got an actuator on it. It's going to be a smoke damper, or because I can see a high temperature limit, it's a combination fire and smoke damper. So you can't tell just by looking at what anything is. You got to go up and investigate. And it can be a pain in the neck if the drawings are gone. When examining some of these jobs, it's amazing that it got passed to begin with. The whole purpose of drywall, there on the left side of the picture, is to protect. That's a rated wall. You can't go cutting the drywall out like that. So in a case like this, you've got to relocate the damper outside of the wall. I'd install a new damper. This is really old and beat up. You could put sheet metal behind that damper shaft, but it's pretty tricky to get it in. But this is definitely a code violation. And I've gotten variation. I got 20 variations of this picture sent to me over the years. We see a lot of dampers installed wrong. And this is something where a sheet metal contractor can come in and replace that damper. And then they can seal up that drywall. Top left, you can see, and this is a retrofit picture where someone sends us and wants an actuator. And I'm like, you're gonna put my actuator in that fire trap? I really don't want it. But they need to clean that up. You can see how bad it is. The bottom one is the archetypical beer can or board and the damper. And that is a certified 1976 beer can. And I got that picture about 2 years ago. So that damper's been sitting there non-functional for how many years? I don't know. On the right side, there's the board holding the damper open. The actuators or the motors can be replaced easily. You just got to know what you're looking at. Next. So here's what UL says about replacements. I don't want to read it to you, but two key points here. One, it refers to a damper as a appliance. Actually, in this one it doesn't, but their previous version did. It refers to it as an appliance, and it can be treated just like it. People aren't afraid to change gas valves, which are handling a dangerous explosive mixture, and they don't get CSA certification or UL certification. They don't need it. You can repair things in the field, and UL is stating here in their marketing guide that you can place actuators in the field. Same thing with the high temperature limit.
Yeah, they're practical. They know that stuff's going to get replaced. The idea that you'd have to replace the entire thing because of one component is, a fallacy.
Yeah, the head of the California State Fire Marshal's office, when I was talking to him about this, said, use common sense, fix it.
Yeah, I haven't ran into a single fire marshal or city inspector that has said anything different. It's usually been a contractor who brings that up, and most of the time that's been a mechanical sheet metal contractor. Yeah, well, they're being careful and they don't know the laws, and people are afraid. I want to write an article called Fear of Fixing, because I get a lot of people afraid to repair their fire smoke dampers. Yeah. They should be afraid not to repair them. We've got a few things backwards. Next. The market in the United States for the contractors out there, it's huge. There are 5 million actuated dampers installed, and there's 8 million curtain dampers. They don't have actuators, but they have a horrible record of being installed wrong or of corrosion keeping them from closing. Only about 10% of installed dampers are in hospitals, and it's probably near 5%, varies. We don't have good records, but 90% of the market is commercial or high-rise residential and government. What time period are those numbers from, 5 million to 8 million? Is that just on replacement, or is that over the last 10 years that have been ordered? Can you give us a little detail? 20 years worth of damper manufacturer sales. So the 5 million and the 8 million. So we know it's going to be larger than that number because there's a lot of them that haven't been touched.
Yeah, but a lot of those real old ones have probably been replaced.
Have they?
Well, it depends on the damper make and model and all that, and whether they've done any rehab in the building.
Yeah.
There are no statistics available for how many of the current products that are manufactured went into replacement and how many were pure new construction.
Yeah.
So this estimate is plus or minus 10%.
All right.
I've tracked the numbers pretty careful for 20 years.
Got better numbers than I do.
Next. So to rub back in the whole service contract idea, if the contractors include service contracts, quotes for damper testing, they're going to get some of the business. It may take a few years to build up knowledge. It is the building owner's responsibility, and the contractor can protect them. The 10 to 30% effective is true. New York State Fire Marshal said that even in the hospitals that they go into, they were finding 30% of dampers defective. And there was a recent University of Maryland study that showed among all the types of dampers, this is actuated as well as curtain, they were seeing 50% at some defect.
That's not surprising at all. When we go over my projects, those defective numbers can vary very large. Yeah.
And what we see is a 20-year-old building is going to have 90% defective. A new building, probably none. The quality in the last 10 years has really jumped up. But just offering those service contracts builds awareness for the future. The cost per damper, it's going to vary by the job. But while the drawings are supposed to be kept around, and sometimes I've heard of some very big bids just finding all the dampers.
Yeah, I completely agree. And just to give everybody a little snippet here, when it comes to cost per damper, it's going to be very specific on the type of damper when you want to do quoting. I mean, we're talking 10 to 15 minutes for a fire smoke damper with a field disconnect switch. You can switch it on and off, or you could be upwards 40 plus minutes for a fire damper where you have very limited access and you have to get to the internals and pull out that fusible link and make sure it works correctly. So it is a very wide range, and it's very specific to type when you do a lot of these type of projects. And the area you're doing it in, whether it's a hospital or whether it's a assisted living facility.
Next. So here's a typical example of, on the left side, old motor, old damper, a lot of stuff. You can't replace that motor. That's not made anymore. But you can tear everything off and you go straight for the damper shaft. You draw a couple, a new actuator. You've actually turned it into a modern damper by using the method on the right. This happened to be a job with 100% effective rate. I was only 22 of them, but every motor in the place was bad, and the dampers were all screwed open, held by a screw. Next. If anyone is looking for instructions on replacement, at that web address there, it starts with the damper, not the actuator. But if you take a good look at all the old dampers, you'll find about 80% of them are easy to replace. They're just a couple on a shaft. 20% of the time, you got to do some investigation. And these instructions will show you what you got there for a damper and then how to replace it.
They're very good directions, especially when it comes to removing shaft springs and other components as you get to an internal return spring on the newer actuators.
Yeah, but you got to know whether there's a lot of the old dampers were two spring, one shaft spring with a fusible link. You leave those alone.
Yep.
Then you got an external spring. You got to remove it. Otherwise, your motor would have to work against its own internal spring and an external spring. And that shortens the life of the motors.
Yep. Couldn't agree more.
So in any of these instructions, we rub in NFPA 80 and 105, and the contents will contain what UL has said. You can submit this form to your either fire marshal or building official. It has a test report on the last page, but it gives you the code information and standard information as well as instructions. Next, the end. It's
We're off
Troy's
to
turn.
start. There we go. Before you start, Troy, I just wanted to mention to everybody, when it comes to the whole reason that we're here, is that fire life safety maintenance agreements don't cover damper testing. They don't cover these different components. Typically what I've run into is a simple checkbox on an annual inspection where they checked fire smoke dampers are operate. So they check to make sure that their relays turn off, and depower. But that's usually it. There is no ongoing maintenance agreement that I've run into for fire life safety contractors that covers damper testing. And so just to give you an idea, that the reason why we get calls, whether it's Troy, Larry, me, is that they're like, what do we do? I get them from fire life safety contractors, I get them from owners, and you're like, well, start showing me drawings. I'll let you go, Troy.
No, that's right. And it really does come down to enforcement. And, when that call comes in, I was looking at the registration for this webinar and very excited to see almost an equal number of AABC and ACG members signing up and attending this webinar. And, both types of companies will be getting the call, from that property manager, for instance, saying, I need your services to perform this testing of dampers or systems. And, in many cases, it's going to take a combined effort, from an ABC member firm and an ACG member firm. The language in NFPA, to your point about the qualifications of testing agencies, we're seeing requirement for fire protection experience, mechanical engineering experience, and test just and balance experience. So it's getting very specific there. And oftentimes that requires a coordinated effort and a combined effort. So NFPA, we'll look at one of the standards that Larry mentioned earlier. NFPA 92 is what governs smoke control systems. So we're going to talk in my section of the presentation here a little bit about systems beyond individual components of, say, fire and smoke dampers. And the definition in NFPA 92 will give us the definition of dedicated versus non-dedicated systems. And a dedicated system will be used for smoke control only, whereas a non-dedicated system also shares the operations with HVAC systems. So we'll give some examples of that. What that means with regard to testing in your dedicated system, your at least for the system dampers, it's going to be at commissioning and then semi-annually, as Larry spelled out earlier, whereas the non-dedicated would be an annual test requirement. And so let's look at some examples of a dedicated smoke control system. Here's one that we would see for stairwell pressurization. So it'd be very important if you're getting called to go out and test this system, whether it's new construction or existing, to understand the design and the sequence of operation and the design intent. So, there's going to be a component of pressure control, because the whole idea is to maintain pressurization in this stairwell. So you might have, pressure sensors, VFD on the fan. You may have some, barometric relief dampers or something like that. And so we need to understand all of the components of the system to properly document, settings and operating characteristics. So the idea here in the stairwell pressurization system is to maintain differential pressure at each floor to maintain that smoke-free environment in the stairwell, but also allow door opening, opening of doors with not too, so that we don't have excessive opening forces on the doors. So our pressure DP, differential pressure across the boundary there at each doorway, we're limited to a range of 0.15 inches to 0.35 inches of water gauge.
It's a
So,
little different for us. We're 0.1 to 0.3 here in Oregon.
okay, so there you go. So that's going to be my next point. This is dependent on your code and your authority having jurisdiction, right? Your local code is going to take precedence on that. And then ultimately, though, what we're trying to do is keep the smoke out, but allow occupants to get to allow egress through those doors. So we're going to measure door opening forces in 3 different components. One being the latch itself, the door latch. So if you have a push bar or if you have like a lever, we need to measure the force to operate that latch, and it needs to be less than 15 pounds. The force to set the door into motion, or we could say break the seal, would be 30 pounds maximum. And then to have the full swing of the door into full open position was also limited to 15 pounds. So 15, 30, and 15.
That's interesting. We don't have the door, that initial one for the latch in our code.
The latch itself. Yeah.
Interesting.
And so, you could have a door hardware, contractor involved as well, making adjustments for anything that's not due to, air pressure, differential pressure, that's causing a problem there.
Yeah, do note that a lot of this, when we go through and when I monitor stuff on the tab side, we typically aim for the low end of that pressure range for the 0.15 for you and 0.1 for me, typically because that door closure force that ends up on some of those doors when the system isn't on tends to, you want to reduce that swing pressure that they have on closure devices, especially to a garage or something that's open and not enclosed. But
yes, absolutely. So yeah, there's several different angles that we need to look at there. When we get into an elevator shaft pressurization system, again, you're going to have some means of pressure control. The door DP requirements are typically less than what we see in the stairwell. In your stairwell, we're talking about a hinged door, but in the elevator, it's more of like a curtain door that could pressure on those doors could cause some binding as they're trying to slide, right? So in the elevator, we typically see a 0.10 to 0.25 as opposed to the 0.15 to 0.35.
Troy, we had a quick question, clarification. What state are you typically doing that 0.15 and 0.35? Because for Oregon and Washington, those are the ones that I'm referencing. And you are, where are you operating primarily?
Most familiar with North Carolina there.
Okay. And ours is for the state fire code, and then the city, any modifications to it.
Okay. Yeah. And again, same principles, right? Maintain the smoke boundary and then the door opening forces, limiting those opening forces for safe egress. Okay, and we can advance there. Now, those were both dedicated systems, right? So now we're going to look at a non-dedicated smoke control system. And in this example, we could look at a day room and a jail. And so we would have typically have smoke zones. And the idea here is to maintain, maintain the smoke, contain the smoke within a zone and not allow transfer into other zones. And so we typically see like a pressurization requirement of differential pressure zone to zone of like a 0.05 to 0.08 inches of water gauge. We want to maintain a tenable environment in the zone of alarm. And so typically that means, keeping the smoke layer above 6 feet or 6 feet off the floor. There's also some visibility requirements such that you can identify like an lighted exit sign from 30 feet away or whatever required distance. That would all be again AHJ specific. But those are some of the parameters that we would be looking at, and this system could share, could utilize the HVAC system and dampers, damper configurations in order to achieve the differential pressures required. So this will be considered a non-dedicated smoke control system. Other examples, you might see like an atrium smoke system that could be dedicated as well. Talk a little bit about tools of the trade. This is one that John shared with me. This is a great tool because this is what we're going to use to measure forces. And John, you might go ahead and just explain to us how we could calibrate this device using some weights.
A lot of people have the smaller handheld version, which is great for just reference door open forces. And you should be able to pull or push with these devices. This specific type, and there's other types, not promoting this single product here, but this is one example. And this is something that you can calibrate the springs and adjust the springs inside of it so that you can use a calibrated weight to make sure that it hasn't tracked in the wrong direction over time as you've dropped it and stored it in your vehicle or whatnot. So definitely you want to get a more robust door pull, door push measurement device. It's also very important at what point, at what height that you're doing it at, and what location. So those are aspects that you want to have as consistent as possible and document that in whenever you're doing reports so that, somebody could repeat exactly what you did.
And no batteries required. So that's
nice. And definitely you don't have to send this one in, if you can do your own in-house calibration with some weights, and you just have to have a record and maintain that. But it's also one you could send into an accredited lab if you needed to.
With that, I'll turn it over to you, John.
All right, for my section, you can stay on if you want, Troy, and Larry, you can feel free to join in at any point. We're going to talk projects and we're going to go over the fun stuff, when it comes to pictures. We try to hit you guys with a lot of the code verbiage and some of the different aspects to this, but when it gets down to it, this type of projects, it takes experience to start finding out all the fun aspects of new environments and what they have. So, changes in code it's actually been very sort of static for damper testing. It's been in the requirement. The question has always been enforcement, which code body, for the most part around the United States have stick to IBC and a few others, and chapters 80, 92, 100 it's in there to test these every 4 years, every commercial building in the United States. The question is, okay, where is enforcement focusing? And that's typically at your higher risk locations here in Oregon, Washington, and Idaho, and even into some parts of Montana, western side. We've seen that assisted living, transitional care, all the types that have never seen damper testing been requested before are getting requested. That they've been doing that since 2017, 18 here, and it's just sort of migrating out. They took a pause for COVID, and then now they're back in. Hey, get your dampers tested. Some places are much more strict when it comes to get it tested the next time I see you. Or you could be like, you need to test it now. And so you can be of great service to your clients by getting it in their budget for this type of work, at least so that they know and can act faster. We know times right now, contractors availability, not so great. So you have a 60-day correction notice and good luck. We talked a bit about fire alarm providers and their maintenance agreements not having damper testing in it and where that sort of stops, and that's their relay devices. And even then, they don't test these individual relay devices. So there's a big need. Larry and Troy would agree that testing across any state, that the need is so there. The question is enforcement, and then who can fill that need. And that's why we're teaching this. There's more projects than I could ever want to do. And I love crawling around ceilings and attics and you name it. And that's why I love this stuff. But generally what the HJs are trying to say is know what you have a plan to get it tested, even a practical plan. So that means getting into the budget, and then, you know, have a timeline for corrections. So as TAB and commissioning providers, you know, have an actual list that becomes their corrections plan. Then have it all documented, which is also a fun part. And we all know documentation of existing buildings is sometimes a layout drawing at best, of an evacuation layout drawing. But here are some options, just real quick. You could do a photo log for critical environments where you know how you left the component. You know, so you could do a picture of it open as you found, or closed as you tested it, and then the second picture would be of it open and returned to operation. So when you leave that damper, especially at a hospital, that you know that you left it in an operating condition in the open position, if that's the normally open position for fail-safe. Then compiling drawings, spreadsheets, you know, the details matter when it comes to this type of stuff. We also put access grade, what size of ladder they need, whether you need to turn off a fan to test it. Code wise, you're supposed to test all this type of stuff at pressure. But as commissioning and tab providers, I don't know if you walked into a building and ever trusted safety relief or safety device, pressure safety devices. The damage that can cause in a shaft or large equipment is definitely not something you want to risk on that first test. And so you have an option. Do you trip the fire alarm system by smoking ahead? Or do you use a field disconnect? Or do you trip a breaker? Do you use the fire alarm panel to trip the whole system? It really depends on what type of building you're in. And somebody has the question, you know, in terms of liability, what insurance do you need to cover? And so, you know, your general, like for my company, I have a general contractor's license and insurance to meet that. So it really is going to depend on the type of work and type of facility you're in. The higher the critical facility, the more likely you're going to need to have good insurance, but then you're also going to be focused a lot more on coordination and avoiding that type of pitfall. The last thing you want though is to be crawling around an attic and all of a sudden you hit a fire sprinkler head and you start swamping an attic. That's my worst fear. So liability insurance, you're going to want to have something to protect you. Or specifically for the project, we do it. It's going to be also based on the size of the project. You know, how high up that food chain you need. This is our sort of standard. This is a very basic one. We range from basic to complex on our spreadsheets because I love spreadsheets still, even though they're dense. But some of the type of information that you'll want in there is the standard inspector, date, pass, fail, remote testing notes if there's a failure, and then specifically what type of failure and who needs to fix it, whether it's electrical contractor, fire alarm, mechanical sheet metal. I also like to put in relay numbers if I can get them, electrical circuit numbers, dimensions, torque size, torque rating, fusible link, model number, temperature rating, any of your temp safety data that's there. That's why I take so many pictures of these projects, what room number it's in, where it serves, the whole gambit there. And then this is one that Larry thought was hilarious when I showed him this image. This right here is a fusible link, if you can see on the right. This is from a project from my coworker, Bruce Gilpin. And I didn't even know what it was. I asked him, and Larry, you asked a few people. We ended up finding the product data for this, and same my coworker did. But that can send that electrical is actually a low voltage to the fusible link, and it can, from the detection from a smoke detector, can send that signal and melt that fusible link. So essentially, it becomes a fire damper that can be closed without a fire. So, Larry, this was the first time you saw that, right?
Right.
Yeah.
But I found it easily enough.
No, there you go. Well, you are
I've never seen one in person.
Yeah, it was definitely unique. This is another one. This is an LC. It's got 165 temp rating on it, and this is a volume adjustable fusible link. This was on a return duct, and so you can adjust the position of the damper. So it's also a volume damper at the same time as a fusible link. To test it, I mean, you can pull it off, but you're going to have to mark the position before you test it. Somebody had a question here is, do you need to test fire dampers on the same schedule as fire smoke dampers? And that's correct. Yes, the same schedule. But Larry, you had a clarification on, was it radiant dampers?
Well, ceiling radiation dampers do not need to be periodically tested.
And those are going to be your fabric style. I think I might have a picture of it. Oh, I'm jumping ahead. I'll get to it. But yeah, ceiling radiation dampers don't have to be tested. I haven't really discussed that one with fire marshals, but I will take Larry at his word and I'll bring it up to my local code official and make sure that they agree. Sometimes access is really great. You can fit your whole body in this type of stuff. And then sometimes access is terrible and it's been spray coated. Any fusible link that you can't visually check to whether or not there is any cracking or any damage, fusible links, you can put it back in as long as you can inspect it. If it's coated with anything, you now have to take it out and you have to put a new one in. So somebody asked what the reasoning for that, and we'll get to that. We'll table that one for the Q&A. Sometimes you have fun catwalks up in ceilings, some of them suspended, but plenty of dampers everywhere in different types of buildings. This is a Barbara Coleman actuator, and we found this one scorching hot. Like you touch it and you'd scald yourself, and it had failed. There is several recalls on damper actuators. This one is one of those, and the internal gears had actually been fused together. And so it was still drawing current and staying nice and hot in the failed position. Larry, do you know there's quite a few out there, aren't there, for recalls from damper manufacturers?
There's only one.
Oh.
The Barbara Coleman CBs were recalled by the Consumer Safety Commission in 2002.
I stand corrected. One. Are they just for those recalls? Do they pay for a new one or anything on those, or do?
No.
No. So that's a quick no.
But there were multiple models that had problems.
Yeah, and if you see this block, you're going to have a few manufacturers, and from Larry's replacement guide, there's going to be several that are branded differently for the same style. We're going to get to one of my first projects, and Troy, Larry, feel free to add your voice to it. This is one of the first projects that I did in 2018, and so this is the type of drawing that you can just gets sent to you. If you're lucky, you have a floor plan with a facilities team, marking out the known locations. This is 3 buildings, 1 site, connected different years. The right side terrace is newer, less than 10 years old, 10, 15 years, I think it's 10 years old. The first floor bottom, it's a 3-story building, first floor, the bottom of the picture is like 1975-ish. And then the top left is a newer, but still older, probably 2000s or something around there, or late 90s. So you get this type of information. Okay, great. This is enough to give you guys a quote. We'll do it T&M, knowing that we're likely going to find a lot more. And that's one clarification I want to make to every single person on this phone call or this webinar, is that for the most part, doing a T&M contract is your best route when you have very little information. And you can go to fixed fee if you have a lot of good information to match the site. Site walks, absolutely necessary unless you have a repeat client. This top left picture here is that ceiling radiation damper. So it's a fabric. So right, Larry, that would be the one that you wouldn't have to test.
That looks like I can't tell what type of damper that is.
We tested
I've never seen that blanket. I don't know what that is.
Yeah, well, there's new ones all the time. And our initial findings here, we found multiple, dampers, both fire dampers and fire smoke dampers failed. We were at a 65% failure rate, which is, like Larry was saying, very high. And a lot of hatches missing, too small of hatches. Here in Oregon and Washington, you need at least 1 square foot. And if you can't get that on a duct that's too small, then you need to make it a removable duct. We've even asked adding 2 hatches so you can get 2 hands in there on smaller ducts. And the fire marshal said no thank you to that and stuck to code. That bottom right picture obviously coated with texture, and you replace that fusible link. It's the type of situation that we're like, okay, this is really bad. But then as we kept going through and we're noticing whole floors of FSDs failed, we're like, there was a bigger problem. And we found that out by tripping the fire alarm system and tripping some duct or smoke detectors, area smoke detectors. And we found that 2 of those 3 buildings, the newer sections, did not have the fire smoke damper relays tied into the fire alarm system. The old relays were found in place and new relays were not when they swapped out the brains of the fire alarm control panel. And we immediately had to take our facility contact, our maintenance lead, and shut the door, talk to them, because also the fire alarm maintenance provider was on site doing their own testing, and I notified them as well. And this is a life safety issue, so I told them we need to start talking, because talking with your fire marshal is a good thing. We need to have a plan in action. We need to notify the parties, and this could become a really bad thing. The reason why the fire marshal needs to get involved is because of how long it's going to take to correct. We also had a fire marshal on site that had told them they needed their dampers tested because of increasing of enforcement. So that it was already on their hit list for the fire marshal, and so we wanted to make sure that that didn't ratchet up. If you're ever in that type of situation, you're going to have to be very real with your contract holder. You work for them. You want to put them in the best position to succeed, both for their occupants, their staff, for their building, because it is something that I've run into a few times, and I had these type of conversations. They happen, mistakes happen, but you want to get everybody on board and to get a plan to fix. The worst thing you want to do is start pointing fingers, and then people get defensive, and then they're not willing to work with you. So you can judge that for yourself. I tend to prefer to make partners and work as a team, and I try to avoid the part of my job that is red flag and alarming, to all parties. So I try to work on an action plan, become valuable. It's up to you how you want to approach it, but I tend to try to work with people. But overall, all the plans got fixed there. We ended up going from, I think, 100 dampers was the original estimate to, I want to say, over 1,000. I want to say somewhere around 1,000 dampers is what we found, because of how many fire dampers were in different areas. So these type of projects can just scale from small big very quickly. You have a responsibility to tell everyone that you found more dampers. And that's why I try to set that expectation from the very beginning, that this might get larger. I think we're getting a little bit long on the tooth when it comes to time. How are we doing, Colleen?
Yep, we've hit time, but we still have a lot of people on, so we'll just continue. If you just want to wrap up here in a few minutes, like 1 to 2 minutes, if you could, then we'll just do a couple questions and then we'll wrap the presentation.
All right, Larry was right. Hospitals we've gone through, high failure rates, non-connected stuff. This project definitely hand-holding the whole time with the client. You run into cables through fire smoke dampers, fire rated stuff staying open because of cables, all sorts of fun stuff. Then you run into dampers you've never seen before, Larry's never seen before, components you can't replace. Try to clean them up, put them back in. You have places where people are like, why is a damper here? And until you get all this tested and know where everything is and what type it is, you can't get rid of it. So, try not to be destructive with your testing, and note that you don't want to destroy it, but you've operated it and it seems functional. So do what you can to not destroy stuff, but you're going to have to replace some stuff. You can have great documentation, great stuff for a fixed project, and then you come into installation that is just terrible and just almost negligent. I would say negligent on this one. And you have to have that conversation with the maintenance team as well as the owner, and then you have to go into potential litigation mode where you tell your team to be quiet in the field. You don't want to talk about it out loud. Just do your work and keep it professional as possible. And you can get medical billings attached to hospitals where there's a question mark on you have an inherent fire alarm system taking control of everything and no records whatsoever, but you have ORs and stuff that should have smoke control systems, and it doesn't have any smoke control sequences. So it's fun. And then you can have those huge air handlers where you should never trust the safety devices on them. This was another high failure rate project. Air handlers didn't shut down, no smoke vent sequences. They had a controls upgrade that messed with the wiring to the VFDs, which were really old. So you run into all sorts of stuff that a commissioning or tab provider, depending on your experience, this could not be done by a mechanical, electrical, or mechanical sheet metal contractor. You need somebody that has good investigation skills, troubleshooting skills. Maybe you do have that type of contractor, who knows? Old fire alarm drawings, fun, old relay descriptions in handwriting, so that you could go track everything down. Importance of fail safe. So you need to fail closed for most circumstances, unless it's smoke control. Those are very important, that you need people with technical capabilities to do. And then you can run into hospitals where they are reducing the fire smoke dampers, and then you want to make sure that they operate correctly by zone, and any changes in zoning for smoke compartmentalization. But in a lot of active hospitals, you can't do that. You can't test and start smoking heads because it's an operating hospital. So we work with a fire alarm provider to trip relays instead and physically trip them, and not, so that we can test the integration part. New building, obviously you could do it completely. An old building, you run into situations where you really need to track down, and that spreadsheet gets huge for who you're going to impact, what rooms you're going to impact. You have to trace ductwork in the drawings, whether it can be done during the day, night, you name it. It ends up being a huge coordination efforts, and your typical, contract could, easily exceed $50,000, $100,000. Try to get those relays with switches in the field, get stuff labeled. Great. Update fire alarm drawings if you can with where the relays are located. Typically it's outside of electrical room. And this is my last one. And then you're going to run into some safety issues for accessing some stuff. This is a shaft, no tie-off points whatsoever. And I'm sure somebody tied off, when they went to go test that duct detector in that shaft. So we typically ask as many access hatches that can be used or get installed so that we aren't in an unsafe condition. And with that, I wrapped up in record time.
Yes, thank you, John. I appreciate it. There's a bunch of you still on with us, so we're just gonna do a couple of these questions that came in for some Q&A. So stick around for just a couple minutes. We did get a lot of good questions, but for the sake of time, I'm just gonna answer or just ask a couple. So the first question for our panel is, what's the reasoning for not requiring testing of the ceiling radiation dampers?
Larry, can you handle that? Do you have an idea?
No, I don't know why. Wait a minute.
Well,
Wait a minute. Question, the top question there from Robin? The same
I
schedule, yes. Which
believe-
question?
about the ceiling radiation.
Oh, I'm looking at the questions on the list. I do not know why ceiling radiation dampers do not need to be tested. I know that they are highly reliable and I've never heard of a failure. There are many more of them than fire and actuated smoke dampers combined, and it would become extremely onerous to try to test all of them every year. But I can't answer the question.
Yeah,
It was not required, and it's not required in the codes.
And so you just gotta know what components you're looking at. So that could definitely be a big saver, especially at a lot of these older locations that were built in the 70s with those ceiling radiation dampers, where they could be on every single outlet in a space.
If the ceiling membrane is fire rated, yes.
Yep. Okay, next question, Colleen.
Yes, we're going up to Robin's question now. It is, do fire dampers need to be tested on the same schedule as fire smoke dampers? If
Yes.
so, how are they tested?
Yes, and
You loosen the fusible link, lower them, bring them back up, make sure that they move smooth, and reconnect the fusible link. That's all that's required.
yeah, and the big trick with a lot of those fire dampers is going to be that those pull tabs have never been unbent before, so you're definitely going to want to have some nice gloves, and then use a nice strong magnets when you're resetting, because a lot of times you're only going to be able to get one hand in there. So you can put strong magnets in the tracks and retract it all the way back up, put those magnets there, and then with one hand you can put the fusible link back in. But you do have to remove that fusible link, see it close all the way completely. You might have to cycle it a few times because those black coil springs can tend to jam a little bit. Use dry lubricant if you need to, and you'll understand very quickly some of the tools that you'll need to test those. And sometimes that's a jack to get in place because of how strong those springs are, right, Troy?
Exactly. Tools of the trade.
Yeah.
I like the magnets though. That's a great idea.
Trust me, little chest piece magnets, amazing. I will recommend you have a lot of them because you also drop and lose them too. So especially in attics with insulation, you can never find them again.
And John, Larry, I will add on the ceiling radiation dampers, those undergo extensive UL certification and testing during manufacturing and so forth, which could, provide the assurances, for their operation. But the big thing right now with the ceiling radiation dampers is specifying static versus dynamic ceiling radiation dampers. And so if there's not a provision to shut down that air handling device or, equipment, you should have a dynamic ceiling radiation damper, and that hasn't always been specified properly. So there are some existing and latent issues out there, many of them.
Yeah.
To Larry's point, there's a lot of those out there.
Agreed. And for fire dampers and any of those fusible link style, I usually test them because they're usually smaller or multi-sets. I always test that with the equipment on. And I typically just worry about the shafts and the larger ones. Colleen, can we get the next question?
Yes, absolutely. And this will be the last question, and then we'll wrap for the day. All right, next question is for critical space, hospital manufacturing, etc., that requires constant air change rates. How do you test the actuator dampers without jeopardizing the built environment?
Well, I'll take the first stab at this. You work nights. You technically, especially in those critical spaces, you end up doing it during a shutdown cycle or a non-occupied cycle where you can get that equipment back up into operation with plenty of time to confirm that everything is back to auto, back to those air change rates that you need, or cleaned. Because we typically have to test and have enough time there for all three of those to happen before patients can be seen. So, and if you're in a patient room, we're talking dust carts and we're talking HEPA filtration, vacuuming with HEPA carts or with HEPA vacuum filters, and all sorts of that coordination efforts to make sure that you don't impact that space or those occupants. Troy, you got anything to add?
No, that's it. Off hours. Is the
Yeah.
I can answer Carrie's question real quick.
Yeah, sure, go ahead.
The fire marshal is always correct, but the code says 24 inches. And if you're going to do 24 inches, you got to put a wrap around it. So technically, the code says one thing, but the fire marshal overrides.
And Carrie's question is about how far away can the actuator and the damper assembly be from the fire rated wall or compartmentalized?
Typically your blades are supposed to be in the plane of the wall.
Correct.
They're guarding the wall. You can put them up to 24 inches out if you put a thermal blanket around them. Or if the fire marshal or building official says something's okay, then it is.
Then document.
They're the ones who judgment. Well, yeah.
All right, thank you for answering that last question in there. I got to squeeze one more in. So thank you, Belimo, again for supporting this webinar, as well as all of our presenters today, John, Larry, and Troy for lending your time. Thank you so much. If you enjoyed this presentation, the Tab Talk webinar series will continue in June on the 15th at 2 p.m. Eastern with a talk on healthcare facility compliance, best practices for an independent AABC total system balance approach with Brian Venn from Mechanical Testing, Inc. And we are searching for a webinar sponsor. So if your company would like more information about AABC Tab Talk webinar sponsorship opportunities, please reach out to AABC headquarters at info@aabc.com. So go ahead and email us if you'd like more information on webinar sponsorship. Thank you everyone for joining us today. Thank you again to the presenters for your time, and enjoy the rest of your day. We'll see you next month.
Thanks, Colleen.
Goodbye, everyone.